Bismillahirrahmanirrahim. My dear students, Assalamu alaikum. So today we will discuss another different type of condensation reaction, which is called Mannich reaction, and this is acid catalyzed condensation reaction. So what are the reactants of this Mannich reaction? So the compounds which are enolic in nature, means all different types of aldehydes and ketones which have alpha hydrogen, so they are enolic in nature. So all the aldehydes and ketones which have alpha hydrogen, they are enolic. They react with a mixture of aldehyde, usually formaldehyde, and a primary and a secondary amine in the presence of acid. It means there are three different types of reagents for the Mannich reaction. First of all, the aldehyde like formaldehyde, which have no active hydrogen. So formaldehyde reacts with an amine, and amine, there is a condition that amine must be primary or secondary. It means that amine must have one hydrogen. The primary amine has two hydrogens, and secondary amine has one hydrogen attached to it. But the tertiary hydrogen cannot be used because it has no hydrogen attached to it. So the reaction starts with formaldehyde, reacts with primary or secondary amine which have at least one hydrogen, and they will give a product which is called an electrophile. This electrophile then will react with third type of reagent, which is aldehyde or ketone, and then the final product is formed. So this type of reaction which takes place in the presence of an acid, it is called the Mannich reaction. So now we move to the mechanism of the Mannich reaction. Here you will see that first step, it has almost three steps. You can divide this Mannich reaction into three steps. In the first step, the formaldehyde or any aldehyde which has no active hydrogen, mostly we use formaldehyde. This formaldehyde reacts with an acid to form a positive carbon. So in this positive carbon, now we will add the secondary or primary amine. Here in this case we have added a secondary amine which has one hydrogen. So this secondary amine reacts with this carbon, and a carbon nitrogen bond is formed, and then the hydrogen is evolved, water is removed from hydroxy from here and hydrogen from here, and you will have this compound. This compound have a positive charge on the nitrogen. This is an electrophile. Now this electrophile reacts with aldehyde and ketone, but first in the second step what happens, that aldehyde or ketone which is enolic in nature, means they have the alpha hydrogen, and they react with the acid. Acid will attach this aldehyde carbon, oxygen sorry, and this hydrogen is removed from the alpha group, and so this is converted into an enol form. You know, we have already seen in the aldol condensation reaction, then the enol form is formed when aldehyde reacts with this aldehyde. Now in third step, actually reaction takes place. The already electrophile which we have formed by the reaction of aldehyde, formaldehyde and amine, they will react with this enol. Now enol, the alpha carbon, this will react to this carbon of this electrophile, and a carbon-carbon bond is formed here. The oxygen proton from here is removed. This will again convert into aldehyde, and so in this way the alpha carbon, the carbon attached to aldehyde, this will become attached to the carbon which is attached to nitrogen. So as a whole you can see that we start with a carbon which compound which has two carbon, and at the end we have 1 to 3 carbons. If this R is H, then we have 3 carbons nitrogen. So in this way we can add one more carbon and one can add nitrogen in this Mannich reaction. So the Mannich reaction is very useful reaction, because with the help of this reaction we can make the nitrogen compounds, we can elongate the carbon chain, and a lot of products applications we will see at the end of the Mannich reaction. We can make a lot of product by this Mannich reaction. Okay, my dear students, now we discuss the Mannich reaction, and we will take the examples of a ketone. The mechanism is similar. The formaldehyde react with proton to acid to give you this carbocation, and the secondary primary amine react with this one, and you will get electrophile. Now here reference is here. Now in this case the ketone will react with acid, and this alpha from any one, it has two alpha carbons, so protons from any one alpha carbon is removed, and you will get a enol. Now this enol in the third step react with the aromatic amine which is attached with formaldehyde, aliphatic amine react with the formaldehyde, and you will get the same product at the end. Okay. Now at the end of this reaction the product is formed, is called Mannich base. So what are the applications of Mannich reactions? First one application is this: when you treat this Mannich base with HCl, you will get alpha beta unsaturated compounds. So first application of the Mannich reaction is that we can prepare alpha beta unsaturated compounds when you treat this Mannich base, that is the end product of the Mannich reaction, with HCl. So what happens? H will be attached to nitrogen, and when this is heated, then this nitrogen is removed and you will get the alpha beta unsaturated compound having double bond. And the second application is this, that when we reduce this product, we will get another aldehyde. And what happens to this, that this aldehyde, which was the starting material, has 3 carbons, and now we have 4 carbons. So in this way, as a whole, we can convert the aldehyde ketones into another aldehyde ketone having 1 more carbon atom. So this is the main application of the alpha beta the organic reaction. And the second application is that we can attach carbon to nitrogen, and nitrogenous compounds can be obtained by using this Mannich reaction.